All right, so welcome to Algebra 2 today. We are jumping into a brand new unit, which is Unit 4. So how are you guys feeling after spring break? We feeling pretty good?
Yeah.
Yeah? Like a little taste of summer, right? We're getting ready for summer break. So today we're going to go over 4.01 through 4.03. So we're starting a brand new unit today, which is not as bad as what we just left, right? So we kind of came off that big hump and we're kind of coming back down to stuff that's a little bit easier for us to do today. Your essential question, which again is not in your notes, I'm going to put that up. If you're in the room, you don't need to write it down. We're going to answer it together at the end. So you guys, if you're with me here, you don't need to write it down. Only if you're at home do you need to write this down. So if you are at home, please pause the recording, write it down, and then press play when you are ready to resume. But it's basically you're going to create your own examples for me today of what would be considered a permutation and a combination problem. So if you're at home, you're creating your own examples of each type. And I'll be giving you lots of examples throughout the session. And my main question to you is, how are they different? How is a permutation different than a combination? And by the end of the day, you'll be able to answer that question. So I'll put this back up again at the very end as well. So grab your notes. Hopefully if you're at home, you printed these out. I did email them to you this morning. It says, for or, use addition. So can you guys circle those things in your notes, please? If we see the word or, we are going to use addition. So let's read this. This unit is all about how many ways can we talk about things? How many combinations of things can we make? So Sheila won a writing contest, so she gets to choose from 1 of 3 trips, 1 of 5 cars, or 1 of 4 appliances. How many ways can she choose her prize? You know, like when you go on, sometimes when you go on TV shows, they let you pick a prize. Sometimes they give you a prize, but sometimes they let you pick a prize. So in this instance, she won a contest. They're going to let her pick a prize. Because they used the word or, and this time I know they made it really big and bold, but do you think they're going to do that on a quiz? No, they're not going to. So go ahead and circle the word or. If we see or, what are we going to do to them? We are going to add. So watch how easy this becomes. I'm going to add 3 plus 5 plus 4. So where did those numbers come from? Let's go back to our text and let's write on it. Let's underline 3, 5, 4. Because I can pick between 3 trips, 5 cars, 4 appliances. So in total, how many choices do I have? 12 choices. I have 12 different prizes I could choose from. Is everybody okay with that idea? It's like if I set them all up on the board for you, right? Here are your 3 trips. Hawaii, Bermuda, Canada. Sorry, my husband's from Canada. 5 different cars, 4 appliances. How many options would you have up there? You would have 12. So when we see the word or, we are going to add. Everybody okay with example 1? Okay, example 2 says, if I see the word and, we're going to multiply. Circle those 2. If I see the word and, I am going to multiply my options together. We like and better. And means more things, right? Sheila won a writing contest, so she gets to choose 1 of 3 trips, 1 of 5 cars, and 1 of 4 appliances. See how she gets to pick 1 from each group, right? 1 of these, 1 of these, 1 of these. So how many different options does she have to choose from? How many combinations does she have? We're going to multiply. So we're going to do 3 times 5 times 4. And she has 60 different ways she can pick a prize.
Those are all the different variations and permutations that she writes.
Exactly. So the 60 are all the different ways that she can pick a prize. And means multiply, or means add. So we're talking lots of combinations today. So now I'm going to have you guys practice 1 or 2. Please, I'd like you to try A and B on your own, and then I will come back and show you the answers. So let's take a few seconds and try out A and B. So the key that you guys should have been looking for are what two words? Tell me.
Or and and.
Or and and. So let's pick them out. This one says or. This one says and. So for or problems, I'm going to do what?
Add.
Add. Or means you add. So what would I get? 12 plus 3, 15. And what would I do for and? Multiply. 3 times 2 times 5. 30. How'd we do? Not too bad? That's 4.1 for you. I put in my painting little example because I just had to do that. I had to pick the stucco for my house, the trim for my house, and the colored door I wanted. So I had lots of different permutations and combinations to choose from when picking house colors. Let me tell you, it took us like a week just to pick colors. My house had like 15 different colors, sample colors on it before I decided what I really wanted.
That's just 401, that's the 401 quiz.
That's 401, and then here's one more piece of 401. 401 is also going to talk about this new idea, which is called a factorial. I'm not sure if I deleted this off your notes or not. Did I? Is this there? It's not there. Okay, so let's add this in. Watch how easy a factorial is. And you're thinking, I don't see factorial. What's a factorial? In math, an exclamation point is a factorial. I've always told you guys from day one, math's like a foreign language, right? You got to learn to speak the language, learn the symbols, learn the vocabulary. So when I see this sign, which we used to know as an exclamation point, in math it's a factorial. What is a factorial? It means we're going to multiply 4 times all of the numbers that come before it. 4 times 3 times 2 times 1 gives me 24. Not hard math, it's just new, just a new idea.
Can you drop the 1?
You can drop the 1, yes. Because when you multiply by 1, it's really just the same. But I just wanted to show you for the sake of showing you, it would go from 4 all the way down to 1. So if I said 10 factorial, what does 10 factorial mean? 10 times 9 times 8 times 7, on and on and on, all the way to 1. That's how factorials work.
Are factorials a part of another part of math? I think I've learned this before, but somewhere else.
Factorials are always part of combinations. So if you've ever learned about combinations in another class, like maybe 7th or 8th grade, you might have briefly touched on combinations. That's when we use factorials. There is one special case, and that's when you have a 0 factorial. 0 factorial actually equals 1. Because here's what a factorial really is. It's saying, how many ways are there to organize 4 objects? For instance, if I put 4 objects in front of you, and you are rearranging them, moving them around, how many ways could you rearrange 4 things? 24 different ways. So how many ways can I reorder 0 things? I can put them one way only. So 0 factorial is kind of a strange case. There are proofs online. I was watching a YouTube video on it this morning just because I was curious to see for sure why 0 factorial 1. There's lots of good math proofs out there. Now obviously I'm not going to make you calculate 10 factorial in your head because that's crazy. So let's talk about how you're going to find that on a calculator. So if here's a calculator, I just want you guys to look in this left-hand section. Does anybody think they see something that would mean factorial? Good. The n with the exclamation point is going to be a factorial. Can you guys circle that in your notes for me, please? So when we're using a calculator, you are either looking for just the exclamation point symbol, or sometimes it might be n with an exclamation point. Or it might say factorial or fact. It might say any of those 3 things. So notice what I typed in. I typed in my n factorial symbol and then the number 10, and it gave me 10 factorial. So when I pushed this button right here, my calculator put factorial, and then I typed in my number. So this is the symbol you're looking for. Do any of you have your cell phones on you? Can we get them out real fast? If you do, I want us just to look for it. So if you swipe straight up, you can select your calculator tool, at least if you're on an iPhone, and then tip your calculator to the side, or tip your phone to the side because that changes it to scientific mode. Can you find your factorial symbol?
Just an exclamation.
Exclamation point. So try 10 exclamation point and see what you get. Or sometimes you have to do the exclamation point first and then do the 10. You should get 3,628,800. Did we find it on our calculator? Because I don't want you doing that by hand. That's a waste of our time. Okay, awesome. And if you don't have your phone when you get home, every computer, you can Google a free calculator, right? So anyone can find a free calculator online. All right, great job. So now we're going to practice some. We're going to do 10 factorial divided by 3 factorial, but not on our calculator. Watch why I'm saying that in a minute. So over here on the right, watch what we're going to do. What does 10 factorial really mean again? Everybody tell me. 10, 9,
down to 1.
okay, 6, 5, 4, 3, 2, 1. What does 3 factorial really mean?
3 times 2 times 1. So you can see it.
Okay, why do you think I wrote the 3, 2, 1 over there on the side? Because they're going to cross out, right? So all I would be left with is 10 times 9 times 8 times 7, all the way to 4. And that answer is, I'm not going to make you do that right now, 604,800. Can you guys all write that down? Sorry, so that's a 604,800. So what did we notice here? Once I wrote out my 10, once I got to what number did they cross off?
3.
Once I got to 3, they crossed off. So let's think about how I can do this one a little bit easier, because I'm not going to write out 100 all the way to 1 and 99 all the way to 1. At what point are they going to cross off? At 99. So really what we can write is we can say 100 times 99 factorial. Then on the bottom I had 99 factorial. So when your factorial matches your factorial, you can cross them off. Do you guys see how that works? So much easier than writing it the whole entire time, right? We know it's going to keep going, 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 but I don't have to write all of those. So by the time I'm done, I'm left with 100. That was cool. So on the top, here's how we could have said it. We could have said 10, 9, 8, 7, 6, 5, 4, 3 factorial. On the bottom, I had 3 factorial. Does that make sense? You're going to write it all the way until the numbers match, and then you don't have to write it anymore.
100 times 99 would just be 100 if it cancels out to 9.
So since the 99 factorials are exactly the same on top and bottom, they totally go away, right? It's like something divided by itself is a 1, so it totally goes away. So all we were left with was the 100. Let's try one more. I know I don't have this one for you, but maybe somewhere on your blank spot of your notes, let's try this one. Let's do 12 factorial divided by 10 factorial. So on top, you should have written 12 times 11 times 10 factorial. On the bottom, you have 10 factorial. So your 2 factorials go away, so you're left with 12 times 11, which is what? 132. Okay, good job. So that is all of 4.01. How do we feel about 4.01, okay? If I see or, it means add. If I see and, it means multiply. If I see factorial, now we understand what an exclamation point means in math. Okay, great job. Moving on to 4.02. Now we're learning about this word called permutations. Can you please underline this twice? Order matters. When we're talking permutations, the order matters. Make sure you're underlining that, highlight it, something. If you want to bring highlighters, that's totally fine. I'm all about making things with colors. So in this example, order matters. How many ways could Santa line up his 9 reindeer? Well, I care if Dasher's first or Dasher's fourth, or you know what I'm saying? The order was going to matter. So when we're talking about permutations, it's what we just did. 9 reindeer, so it's really going to be 9 factorial. How many ways are there to arrange 9 reindeer? That's 9 factorial. So 9 times 8 times 7 all the way to 1. So there are 362,880 options to arrange his 9 reindeer. Isn't that crazy? That's a lot. That's a lot. But I'm going to change the question on you slightly. Now it says, how many ways could Santa line up his 9 reindeer if Rudolph must always be in front? Isn't it true he always has Rudolph first? Is that right? Because he has like the bright red nose, right? So Rudolph always has to be first. So that means how many of the reindeer are really have the option to switch places? What do you guys think? So really only 8 reindeer have the option to switch places. So we're really talking 8 factorial for this problem. So Rudolph is first. Rudolph is first. Here are the other 8 reindeer. Did you guys see how that question changed just slightly? Because how many could switch places that time? Just 8 of them. So that's the difference. Look how factorials really changed though. When we are talking 9 reindeer, we are at 362,000. When we're talking 8 reindeer, it bumps it down to 40,000. See how each factorial, it's like exponentially growing, right? It's getting bigger and bigger and bigger. Okay, good job. Questions so far? I know you're thinking, how am I going to use this? And I'll show you in just a minute. So now we're going to put permutations and factorials together, and you're thinking, oh my gosh, that looks scary. It's not that scary. Just stick with me here. So if I'm doing permutations, what a permutation is, it's a combination of things when order matters. Okay, so it's combining things and putting things in an order when your order does matter. So here's my blank formula. N stands for how many total items we're talking about. R stands for how many you're choosing at a time. So what I mean by that is, here I have 10 total house colors to choose from, but I'm only going to pick 2 house colors at a time. I want to know how many different color options do I have. So watch what we're going to do. On the top goes n factorial. So which one of my 2 numbers is n? What do you guys say? 10. Perfect. So 10 factorial is going on top. Okay, so stick with me for right now. So when I give it to you in this format, the capital P stands for permutation. N is the total number of items I have to choose from, but R is how many I'm picking at one time. So my 10 is going to go on top. Now on the bottom, I'm supposed to do n minus r factorial. So what's going to go on the bottom?
8 factorial.
Okay, so 10 minus 2 factorial. Good job. So on top, I have 10 factorial. On the bottom, I have 8 factorial. We can solve that now because we just did on the last couple slides, right? So let's do that. So I'm going to write 10 times 9 times 8 factorial. And on the bottom, I have 8 factorial. So what's my answer? 90. Good job. So my 8 factorials cancel. 10 times 9 is 90. So if you have 10 color options, but you can only pick 2 at a time, how many different choices do you have to choose from? 90 different choices. Still a lot. So it took us a week to decide on our house colors. Are there any questions about any of the steps for this first example? So we're just taking N and R and we're plugging them in. Okay, so let's try again. An artist has 7 different paintings. If he chooses to hang 5 of the paintings in a row, how many arrangements are possible? Has your mom or dad ever tried to hang paintings on a wall and they're not quite sure how many they want to put in a space, and that's kind of this problem. So let's first write it in permutation notation. So let's put our capital P. How many total paintings am I talking about? 7. How many am I picking at a time?
2.
5. I'm picking 5 at a time. Okay, so let's go back to my formula. I'm going to rewrite my formula first. Let's see if we can plug my numbers in now. Why don't I give you a minute to try? So check your work with mine. So your n was 7, so 7 factorial goes on top. On the bottom is n minus r, so 7 minus 5 goes on the bottom. So the top we have 7 factorial, the bottom we have 2 factorial. So on the top I'm going to say 7 times 6 times 5 times 4 times 2 factorial, all divided by 2 factorial. So those two cross off and I'm kind of left with this. So it's totally fine to grab a calculator to do 7 times 6 times 5 times 4 times 3, and we should get 2,520. Good job. So I hope that what you're seeing is that the equation looks a little scary, like it looks a little weird. We're not used to having like these two numbers going on next to my p. We're not used to this factorial symbol. This is all new stuff. But once I plug my numbers in, the math's not that bad, right? It's really not that bad, especially when you can use a calculator to do this portion. So if your mom or dad's trying to pick from 7 different paintings to hang 5 at a time, they have 2,500 options of the ways that they can arrange those 5 paintings. That's a lot of options.
Mrs. G?
Yes.
If they're hanging 5 of the paintings in a row out of 7, and that leaves 2 that they can rearrange with?
No, they're saying 2 are going to be left off the wall.
Oh.
They're only going to be putting 5 on the wall.
Oh, okay.
Does that make sense?
I was getting confused.
No problem. We're going to do problems in a second where you have 7 to start with and you're going to hang all 7 on the wall. But I'm just talking right now about what happens when these are different numbers. But we're going to get to when we do all of them, when we're using all at the same time. Open those. That was the work. Okay, so let's try another one. Speak of what we were just talking about. How many ways could 5 different books be lined up on a shelf? You might be thinking, they didn't give me enough information, but they kind of did. So here we go. Put our P there. How many total books are there? 5. Now, remember, your first number is how many total there are. The second number is how many we're choosing at a time. So if I start with 5, and in this case, they want to put all 5 up on the shelf, how many are we picking at a time? How many are we going to use total? 5. So this time it's 5 and 5. So let's compare this to the last one just real fast. I want to make sure you guys got this. So in this example, 7 paintings total, he's choosing to hang 5 of them. That's how we got our 7 and 5. This time, how many books were we talking total? 5. How many books are they putting on the shelf? 5. They're using 5 and 5. So let's try our formula. N factorial over n minus r factorial. Please try and plug in your numbers and see what you get. So we should have gotten 5 factorial over 0 factorial. Everybody with me? But what is 0 factorial? It's that weird rule we learned about earlier. It's really a 1. So my answer is really 5 factorial. So you would be allowed to use a calculator, work out 5 factorial. So you could type in 5 times 4 times 3 times 2, or you could do the 5 with the little factorial symbol. And when we try it, we get 120 different ways to organize those books. How do we do? So far, are we hanging in there? Yes.
One other thing, you just do like factorial instead of doing all the extra steps.
Yes. So what you're going to realize, and what Taylor's saying, is when the number's the same, can't I just realize that that's a 5 factorial? Like instead of doing this whole bottom section too? Yes. It's like one that we did at the beginning today when I said, how many ways are there? I forget what the question was. But yes. When you're only talking about one specific number and you're using that number the whole time, yes, you can just do the 5 factorial. I just wanted to show you that it still works in this formula too. If you forget and you're like, oh, I always need to use the formula, you'll still get the same answer. Okay, great job. So now we're jumping in still to 4.02. This one's very similar to the last one. So let me give you a minute to try this one. How many ways can 4 people finish a marathon? Some of you already have your answer. That was fast. If you remember the shortcut, it's fast. So we get 4 factorial over 0 factorial, which is really over 1. So what's 4 factorial? 24. Good job. 4 times 3, 12. 12 times 2, 24. So 4 people in a race, how many different options are there for getting first, second, third, fourth place? There's 24 different options. You may be thinking, wow, it doesn't seem like there'd be that many. But there are. If you laid out 4 crayons on your table and you tried to change their order, there'd be 24 different combinations of their order. So math helps us get the right amount of numbers without us making the mistake by moving things by hand. Like the old shell game, moving shells around. So now we're going to get into a slightly different kind of formula. And this one says it's still a permutation, but this time I have like objects. Can you circle those 2 words? This time we're going to have like objects. So what does it mean to have a like object? Well, it means if I'm talking about crayons, what if I had a yellow, and a green crayon? How many different ways is there really to organize those things? Well, we're going to talk about it. It's actually more than 2. We're going to deal with this example with the letters boo. Okay, so for the sake of just showing you different colors, my B is in black. One of my O's is in red, and I know that didn't come up in color on yours, but that's okay. And one of my O's is green. So look, here's a boo with the red first, then the green. Here's a boo with the green first, and then the red. But here's the question. Doesn't it still say boo? Still just says boo. So really, this is just one permutation. Then I have OBO, OBO, OOB, OOB. So really, how many unique ones did I have? 1, 2, 3. There are 3 permutations when you have the letters BOO. So just like when we just talked about yellow, yellow, green, there's really 3 different ways you can organize it. You could say yellow, yellow, green, yellow, green, yellow, and what would be my last one? Green, yellow, yellow. Okay, so there's really 3 different options. But how am I going to use a formula to determine that? So let me show you. It's this new formula that's down here at the bottom. We're going to do the permutation from n to n, which means permutation from 3 to 3. Then on the bottom we have these 2 new letters, P factorial, Q factorial. What these stand for are how many different objects do you see? Well, how many O's did I have? 2. How many B's did I have? 1. So that's really what's going on the bottom. You're going to tell me how many times did you see each individual object. So how many times did I see the O? 2. How many times did I see the B? 1.
Doesn't matter which.
Doesn't matter which one's first because they're just multiplied. Yeah, so it doesn't matter. So let's do 3 permutation 3 first, which we learned the shortcut is really that really means what? 3 factorial. So I have 3 factorial on top. On the bottom, I really just have 2 factorial. So if I want to write them all out, I don't have to, but I can.
So 1's also just 1. Basically.
Yeah, right, because 1 can't multiply by anything but itself, so 1's just 1. So we got 3. Using the formula, we got 3, and also by writing it out, we got 3. Are we okay with that? So when I have like objects, because sometimes we could have something that looks like this. I can't think of a better word, I'm sorry. Like if I had that, right? How many times do you see the T? 2. How many times do you see the O? 2. So in that case, my bottom would change just a little bit. See how P represents one object, Q represents how many times you see the other object. Okay. So now we're going to get into 4.03, which is combinations. So let's highlight the word combinations and circle this. Order does not matter. That's different, right? With permutations, order matters. Combinations, order does not matter. That's the big difference of the day, part of the essential question. So permutations, order matters. Combinations does not matter. The order doesn't matter. And here's why. Think about my example. The student body takes the poll to select the new school colors. Of the 9 colors to choose from, how many ways could Felix select 6? We don't care what order the colors are in. They're just polling the students. Okay, so we're going to use combinations when the order doesn't matter. Santa's reindeer, he wanted to know how many different orders they could come in. He cared about the order. Here we don't care about what order people are picking colors. So we're going to try one. This is a new formula for us, and it's right here. So notice when it's a combination, what letter are they using? C. When it was a permutation, what letter did we use? P, right? So one's a P, one's a C. My N and my R are still the same. So N is the total number we're talking about. R is how many we're picking at a time. Do we see that it's almost the exact same formula? What's the only difference in these two formulas? What do you guys see? There's just the extra R factorial at the end. That's the only difference. When are we going to use the combination again? When order does not matter. Order doesn't matter. I don't care what order people are picking colors for the school. I don't care. So let's try it. So I have my combination from 9 to 6. And let's plug my numbers in. So on top, we're going to get 9 factorial. On the bottom, we get 9 minus 6 factorial. And then 6 factorial. Everybody okay plugging the numbers in? So far, so good?
Are the formulas like already now they should be there on the bottom?
Maybe.
No.
Yeah, possibly. Usually the first time I show it to you guys, I give you all the steps, and then the next time when you do it, you're going to have to add it in yourself. So I try and give you a little bit of both. So how did they do the 9 factorial? They wrote out 9 times 8 times 7 times 6 factorial. Why did they stop at 6 factorial? Because they already had a 6 factorial on the bottom. Did you guys see that? So let me stop right there. They stopped at 6 factorial because they already had one on the bottom. And then my 9 minus 6 becomes 3 factorial, which is really 3 times 2 times 1. So I'm going to cross off these 6's and let's see what we have left. So on top I have 987. On the bottom I have 321. So let me pause and I'll go back. So 9 factorial on top. We know it's 9, 8, 7, 6, 5, 4, 3, 2, 1. They stopped at 6 because I had a 6 on the bottom. When we have ones that match, we're going to stop right there because I get to cross them off. In my parentheses, 9 minus 6 gave me 3 factorial. So that means on the top I have 987. On the bottom I have 321. So by the time I'm done, calculators, yes? I have the answer too, but I'm just making sure we're practicing. 84? Yes? Okay. Anna, do you have a question?
No.
Okay. How did we do? It just added the extra R, right? Just one extra little thing from what we did on the last slide. So there are 84 different options that these students could choose when picking out of 9 total school colors. They can pick 6 at a time. There's 84 different options to pick from. Okay, let's try this one. So Gunnar wants to buy 12 DVDs, but he can only buy 2. Because you know sometimes you go to the store and you would love to have like this whole selection, but your money limits you to how many you can buy, right? So how many options do you guys have? Do we care about the order you're buying DVDs in? We don't care. We just want to know how many options we have. So this becomes a combination formula. So take a quick minute, try this one on your own, and then I will come up and put the steps up there. So of course we would love to buy 12, but we only have the money for 2. So on top I have 12 factorial. On the bottom, 12 minus 2 factorial, and then a 2 factorial. So on the bottom you guys got 10 factorial, 2 factorial, correct? So that means on the top I only need to write my 12 and my 11, and then I can write 10 factorial, because then my 10s are going to cancel. So on top I get 12 times 11, 132 I think. And on the bottom we get 2 factorial, so 2 times 1 is just 2. What do I get, final answer?
66.
66. Great job. So if you go to the store, there's 12 DVDs you want, but you can only buy 2. You have 66 different options of buying combinations of 2 DVDs at a time.
Does it matter what order you cross out the bottom in? Like, could you have done 12 and 2 instead of...
I don't know the order that is going to happen.
Oh, you mean here?
On the right there?
Yeah.
At the end?
Mm-hmm.
Could you have gone all the way down to 2 instead?
Oh, sure. Certainly. Yeah. Yeah. So the question is, could I have gone all the way down to 2 and then crossed off my 2 factorials? Yes. Yes is the answer. You're going to get the same answer. Your problem just would have been a little bit longer, because I was able to cross off at the 10. Does that make sense? Same answer, though.
So if you were write down all the way up to the 2, and then just have the 2 and then write the 10.
Sure. Yep. It would still be the same. You don't ever have to cross off anything. If you want to write 10 all the way to 1, 10 all the way to 1, 2 all the way to 1 each time and have them be really long, fine. You get the same answer. This is just a quick shortcut for whenever you see something that matches factorial-wise, you can cross them off. Good job. Okay, so to everybody take a deep breath before we start. Deep breath. Whew. So I have one last thing just to show you briefly. This is not coming until Friday, maybe Monday. Okay, we'll do this again next week. Before I show you anything else, if I used to give you a problem that looks like this, cubed, we used to write it like this, right? X plus 2, x plus 2, x plus 2, right? And we could multiply that all through, like do your FOIL method, right? Then FOIL again for the other one. We could do all that. Well, now we're giving you a new theorem for how you can find that answer. So instead of writing them out, because think about it, if it's just to the third, okay, you could write them out to the third and we could do it by hand, no big deal. What if I change that to the 13th? You want to write that out 13 times and FOIL 13 times? No way. So there is a shortcut method, and it's called the binomial theorem. So don't panic on me. This was last unit. When I see that E, what does E mean I'm doing to the parts of my problem? I'm adding them. Yes, that's all I wanted you guys to come out of that. So when I see the E, what does that E symbol mean? It's sigma. It means we're adding all the pieces of my problem together. So to add these pieces of the problem together, we have 3 pieces of the puzzle. We have a combination piece, we have an X piece, and a Y piece. So the X is going to come from your first term, the Y is going to come from your second term. Okay, so it's not as scary as it first appears. It's just going to be a summation problem, 3 pieces to the problem, a combination portion, an X portion, and a Y portion. Okay, so now I'm going to show you one. So instead of saying X plus Y, we're going to try it for X plus 3. I think I blocked off these notes because I wanted you to write them out, correct? Nope. I didn't block them out?
No.
Oh, I did.
Oh, they just don't exist.
Oh, yeah, it's just the top line. Okay, so here we are. So on your notes, please add this down. This is our last problem for the day. We're going to put X plus 3 cubed. That's the problem we're trying to solve. I want you to just take a quick minute, copy down these steps, then we're going to come back and talk about them. So just pause and write them down. I should have left that, at least that portion for you, sorry. Next time. Yeah, so right above the black part, just add that there. Oh, that is there? Oh, okay, perfect. Okay. Okay, I did give you most of it. Thank you. So I did give you this part. So what does this say? Well, if I come back to my formula, see it's my C with my N and my R. Where do I find my N? Right there. So what's my N going to be? 3. Where do I find my R? Right here. R is always 0. So we're always going to start at 0, and then we're always going to go to whatever number they're telling me to go to. So before we go any further, everybody check out your C's. Do we see a pattern that's happening to my C's? Look at this C. I'm going to highlight them. Look at this C, this C, this C, this C. What's happening to them?
They're going up by 1 progressive.
Perfect. That's exactly what I wanted you to see. So what's really happening? Well, we're starting at N and we're going to R. Do you guys remember when we did these? We started at 0, plugged in 0, then what did we have to plug in? Can we remember? Like if I put a 0 and a 3 up here, this was last unit. 0 and a 3. We had our equation. First I'd have to plug in a 0, then I'd have to plug in a 1, then a 2, and then I would plug in a 3. That's how these summations work. I started here and I ended here. So look at my C's. I start at 0, then I'm plugging in a 1, then a 2, then a 3. That's what we did last unit. Now for my X portion, what do you guys see happening to your X's? X, 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 X. What's happening to your X's? It's going down by 1. Do you remember last unit? I know, again, it's been a while before spring break. Whenever we see that symbol, the N minus R, that meant previous term. Is that coming back to us now? Anytime it was the N minus R, that meant previous term. So if I'm starting at 3, the previous term would be 2. The previous term would be 1. Previous term would be 0. And then lastly, for your Y's, my Y was a 3. My Y was a 3. And again, it's raised to the R. So the first time I'm plugging in 0, then a 1, then a 2, then a 3. So this formula is really all these small pieces of the puzzle that we did last unit. The only thing we've never done before are just the C's, which is what we're learning this unit. So where does that get us? That looks crazy scary, Miss Giesbrecht. So where does that get us is right here. Don't want to show you all of that just yet. There's like too much going on. Let me grab white. Okay, so underneath it, x cubed. What's 3 to the 0 power? What's anything to 0 power? 1. Anything to 0 power is 1. So I'm not going to write it. Let's come over here. Then I have x squared times 3 to the first is 3. I have an next one. 3 squared is 9. What about x to the 0? 1. Good. And 3 to the third? 27. I kind of have some pieces of the puzzle now. The only parts that I'm missing are my C's. Only parts I'm missing are my C's. How do I do my C's? The C's are what we've been doing all day today. Not all day, but like the last part of the day. So I'm going to just do a little arrow down here for the first one. Can you guys do that with me? Somewhere in your blank space. We're going to just fill out this boxed area. So we're going to figure out 3C0. The way we do that was going back to our formula. It's 3 factorial divided by 3 minus 0 factorial, 0 factorial. That's our combination formula that we did on the last page. My n factorial, n minus r factorial, r factorial. Remember that formula last page, a couple slides ago? So we just have to work this out. So 3 factorial, well, we'll leave that. On the bottom, 3 minus 0 factorial, what's that going to give me? 3. So on top I have 3, on the bottom I have 3. And then what's the 0 factorial portion? 1. So what's this whole answer?
1.
Good job. So this whole 3C0 just became a 1. So that's the first part of my problem. I have 1x cubed. Let's try one more. Let's do 3C1. Let's do 3C1. Let's plug it back into my formula. 3 factorial divided by 3 minus 1 factorial, 1 factorial. Just work on that bottom portion for just a second. So on the bottom, you guys should have gotten 2 factorial, 1 factorial. So your 2 factorials can cancel, and we're left with 3 divided by 1, which is just 3. So what goes in front of my x squared times 3? 3. So if I'm rewriting that second term, 3x squared 3 looks funny. Would you agree? That looks weird. How should I rewrite 3x squared 3? 9x squared. Because all 3 of those are just multiplied together. We just did the first 2 terms together. We got our x cubed, we got our 9x squared. You would have 2 more to go, but I'm just going to stop right where we're at because we kind of get the idea. And plus, this is not till Friday or maybe Monday. So I just wanted to touch bases with you, make sure we were understanding. Today's, have a great week, of course. Today's essential question was to create your own written example of what would be considered a permutation and what would be considered a combination. So let's remind ourselves of how they're the same and different. Here was my permutation example. An artist has 7 different paintings. If he chooses to hang 5 in a row, how many arrangements are possible? Here's my combination example. You want to buy 12 DVDs, you can only buy 2. So if you're at home, you're going to create an example just like mine here. You're not solving it, you're just writing an example, writing a problem. But I do want you to explain to me, how are the 2 different? Like, how do I know this first one's permutation? How do I know the second one's combination? Make sure you label them in your Dropbox. So I would write permutation, then give my example. Combination, then give my example. All right, thanks guys. Have a great day. If you're here in person, we're going to answer this question together after I stop the recording. Thanks.